guys, in the previous lecture we had a brief idea about MapReduce. We saw how MapReduce were working at the bigger scale. So we discussed about the reduce function, what the mapper function does and what the reduce function does. In this lecture we'll be seeing some details on keys and values, how its data structure work in MapReduce. So when we program any MapReduce program to process our data, it has to specify two functions as we discussed earlier. It's map, which is the mapper, and reducer. So the map function and the reduce function. These implements the mapper and the reducer in our MapReduce program. So in MapReduce, data elements are always structured as keys and values pairs. First we map them in the mapping part, where mapper goes and maps the keys and their values, and then we shuffle it. After shuffling, we reduce them. We count the number of keys and values that are there. So the map and reduce function receive and emit key K and V pairs, or keys and value pairs. So we see input splits in keys and value pairs, map function getting processed, and we get our intermediate output as K dash and V dash pairs. Then comes the reduce part, and our final output is K double dash. So we added up in the reduce part, we reduced them and added it up, like counting the number of fruits in your basket. First you put the fruits in the basket, you label orange 1, apple 1, and in the reduce part what you do is count the number of apples, count the number of oranges. That is what we are doing here. Hope you are able to make sense of this. So a chunk of file, the course name of 15 to 40 distributed systems. So firstly we map them into keys and value pairs, then reduce them. So here we are mapping them. Firstly we map them and then reduce them. This is our intermediate output of mapping, and here comes the reduce part, and reduced it to our keys and value pairs. So we saw some basics, discussed some basics about MapReduce. We take a closer look now. We'll see the combiner functions, how the combiner works, task and job scheduling, and fault tolerance. So let's get started. So we firstly loaded our files from the HDFS store into an input format. We've then split it up. We then use RecordReaders. So we use these to read different kinds of data, like structured data, unstructured data. We can use RecordReaders, and we inputted them into mapping values. We got our intermediate key value pairs. Then we can perform a sorting operation. We can sort them on low to high, high to low, and then we reduce them. So this is the shuffling part. This is the intermediate key value pairs. Then this is the final output. And then again we write it back to HDFS store, and then again the process continues. So the input files, the main task. So firstly we need the input files. To process any output, we need input files. Input files are where data for the map task are initially stored. So whenever we perform a mapping task, all the initially stored data is in the input files. Input files typically reside in the distributed file system. The output is arbitrary line-based log files, binary files, multi-line input records, or something totally different. We don't know. So, how the input files are split up and read is defined by the input format. So the kind of material we are using to build a building, to build a skyscraper, that will be at the output. If we are using cement, so we'll get a cement building. So how our input would be is what that will be defined by the input format. So what it does is it selects the files that should be used for input and then defines the input split that breaks the file. Essentially, it provides a factory for record reader objects that read the file. So these are the different kinds of input format that we can use. We can use text input format, we can use key value input format, or we can also use sequence file format, file input format. It's a Hadoop distributed high performance binary format. We can use it to reprocess unstructured data. Key value input format parses them into keys and value pairs. Text input format, we need like lines of text. So input splits. So we need to split it with a delimiter or something. So by input, this Hadoop 2.6 and 3.0 breaks the file into 64 MB splits. We can also customize that. Each map corresponds to a single input split. Each split that is there is a mapping task, or each mapping task is corresponding to a single input split. By dividing the file into splits, we are allowing several mapping tasks to operate on a single large file in parallel distributed operating system. If the file is very large, this can improve the performance significantly. So as we discussed earlier, we can process 1 terabyte of data in 207 seconds. We'll be seeing some practical bases as well. So discussing some more details of RecordReader. What is RecordReader? So the input split that defines a slice of work but does not describe how to access it. We do not know how to access it. It's just an input slice that defines a slice of work, but it does not describe how can we access it. It just loads the data from its source and converts it to key value pairs. That was the record reader is doing. It's reading the records and choosing the suitable pairs for reading by mappers. The record reader is invoked repeatedly on the input until the entire split is consumed. And each invocation of the record leads to another call of user-defined map function. So we always need to define a user-defined map function to invoke or use record readers. The mappers also perform a user-defined work within the first phase of MapReduce program, that is the map phase. Mappers process the splits. Let's summarize it. The reducer performs the user-defined work within the second phase of MapReduce program, that is the reduce phase. Reducer processes the partitions. There's another thing called bucketing over here, which we'll be discussing in the further lectures. For each key in partition assigned to a reducer, the reducer is triggered once. For each of the key, it gets triggered once. It will get triggered once for apple, one for orange. It will not be like the mapper phase that is mapping each and every record. It will be reducing. It will be assigned. Each key in the partition assigned to a reducer, the reducer is triggered once. That's the logic behind here. Each mapper may emit keys and value pairs to any reduced task. After the reduced task, it comes to partitioner. So firstly we are shuffling and then we are partitioning. Therefore the map node must all agree where to send different pieces of intermediate output. The partitioner class determines which reduce task or partition a given key value pair will be assigned to. This is the job of partitioner class. Which key value pair will it be assigned to? The default partitioner computes a hash value for a given key, assign it to a partition, and based on this result. Partitioner hashing a value which is being computed for a given key and then assign it to partition. Whatever result it got will be assigned to the partition. Then comes the sorting part, where each reduced task is responsible for reducing the value associated with the several intermediate keys. Intermediate keys of a single partition are automatically merged. We don't have to manually merge them. It's sorted by MapReduce engine, therefore they are presented to the respective reduced task. Reduced tasks often apply the user-defined reduce function on merged and sorted partitions and output the final results. The reduced task can be viewed as consisting of three stages: the shuffle, merge and sort, and reduce stages. As we discussed, the output format. So we did the input format, we did the record reader, now comes the output format. The output format class defines the key value pair produced by the reducer that are being written to the output files. The subclasses of output files provided by Hadoop allows writing to either local disk or HDFS. And now question comes, where would it be faster to access my files? Would it be faster to access my files on my local disk or on HDFS? Take a moment or two and think about it. Once you have an answer, you can resume the lecture. So the answer is HDFS. It will be faster to store data on our HDFS for faster retrieval, schedule, job processing, scheduling different jobs on different nodes. Several output formats are provided by Hadoop: the text output format, sequence file output format, and the null output format. So now you would be wondering, why would we want to choose null output format that generate no files? So this also will be discussing in the further tutorials. So sequence file output format, it writes the suitable for reading into subsequent MapReduce jobs, while text of output format default or write lines in key value format, which is tab separated. So hope you guys enjoyed this lecture. In the next lecture we'll be discussing about combiner functions. What are the role of combiner and how do they work in our MapReduce program. If you guys have any questions or any doubts, you can ask them in the comment section below. We'll be more than happy to assist you. Hope you guys enjoyed this lecture. Thank you guys and happy learning.